Our next lesson is called Simple and Compound Interest. So first, I'd like to recall that we already discussed simple interest in a prior chapter. Simple interest is computed only on the principal. So it is used commonly in consumer lending and in mortgage loans. So if you recall from principal interest, we gained the same exact amount every single time. So simple interest lended itself to being a linear situation because the interest was always the same, because the interest was always only calculated on the principal, and that principal amount that you put in was the same every single time. This time in our new chapter, we can talk about the other type of interest that exists, compound interest. And compound interest is computed on the principal and the interest. So when using compound interest, you want to think of it like your interest earns interest. So the difference here is that when you take the percentage, you're going to get to take the percentage of your most recent total rather than always having to go back to only the original amount that you put in. So let's take a look and investigate with the formula and a situation so you can see the difference between this new compound interest versus our simple interest. So you have our formula. A is still the accrued amount. P is the principal or starting amount. R is the interest rate. Just make sure, again, you express it as a decimal. And then N is going to be the number of years. So when we look at example 1, it says Jack has $500 to invest. The bank offers an interest rate of 6%, and the keywords are compounded annually, not simple interest. So in the first question, how much money will Jack have after 1 year? We're going to just calculate the interest. So I would do 500, which is the principal amount, times the rate, which is 0.06, times the time, which is 1 year. And I'm going to do that right now for this first year because it's only 1 year. But when we look at the table of values and we look what we do when we go forward, I'll show you why we need the new formula. So here we would do 500 times 0.06 times 1, and we would get $30. So when you calculate the total, you would do the principal amount that you put in plus your $30 interest for a total of $530. So that feels very familiar. The first year, you kind of can't really tell much of the difference. But it's when we start to look at B, let's continue to calculate the interest in total that Jack will earn if he invests for 2 years, 3 years, and so on. And when we organize it in the chart, that we'll see the difference between this and our old simple interest. So for compounded annually, let's start with time of 0. 0 would be our principal amount. So I didn't earn any interest. I just put 500 because that's the principal amount that I borrowed. Now, after year 1, we just calculated that would be $30 for a total of $530. So then, when we look at year 2, this is when things start to change. In simple interest, I would just go back and find 6% of the principal amount again. I'd get the same thing, and I'd see a constant rate of change, and I would see it growing linearly. Here, I am going to now find 6% of my most recent amount. So that means I'm going to find 6% of my recent total, which was 530. When I do that, I'm doing 0.06 instead of 6%. Remember, 0.06 times 530, and I get $31.80. So you can see it is not the same amount as I got the year before. And I will then add the $31.80 to 530 to get $561.80. Then, in order to calculate the third year, I'm going to do 6% of my most recent total, which is 561.80. So I'll take 561.80 and times it by 0.06. Remember, 6% as a decimal. When I do that, I'm going to get 33.708. And yes, I know this is money. So does 0.708 really make sense? No. But for the purpose of what I'm trying to show you overall, for right now, we're going to leave these decimals as they are, even though we know money really should be to the nearest hundredth. So if I add 33.708 to my most recent total of 561.80, I'm going to get 595.508. So then in year 4, I would calculate 6% of that recent total, 595.508. And I would end up with 35.73048. And then I will take that amount, since it was interest, and add it to the 595 number to get 631.23848. So when we look at this, we can tell it's not simple interest. If it was simple interest, I'd be getting the same amount every time. That's not happening here. In compound interest, you're finding the percentage of your most recent total. So when I look at the pattern from here to here, here to here, here to here, here to here, I'm trying to figure out a ratio, a factor, not an adding or subtracting pattern. So in order to do that, you can take any value and put it over the one that came before it. So let's take a look at the calculations on our graphing calculator. So if I do 530 divided by 500, I get 1.06. Let's do our second year over our first year. If I do 561.80 and I divide it by 530, I get 1.06. Let's do the 595.508 divided by the 561.80. I get 1.06. And if I do the last one, 631.23848, and I divide it by the one that came before it, 595.508, and I hit enter, I get 1.06. So I'm getting the same exact factor every single time. So back on here, we'll do times 1.06 times 1.06 times 1.06 times 1.06. And if we wanted to continue the table, we would just take that total old and keep timesing by 1.06. Now, when you think of 1.06, that's 106%. That makes sense. The way they're doing this is you're taking the total and you're adding that percentage of interest. So this is where the formula comes in that we went over up here. Now you can see why we're doing A equals P, and then we're doing 1 plus R in parentheses to the N, because we are taking 100% of what we already had, but in addition, adding the percentage that we owed. And that's always going to be on our most recent total. This is not just on the principal. This is on everything. So in the write your formula section, the generic formula is A equals P times 1 plus R to the N. For us, our formula would be A equals our principal amount was 500. And then in parentheses, we do 1 plus 0.06 and then to the N. Or some people will write it as A equals 500, and then they'll just add those two together, 1.06 to the N, which is the rate that we saw when we did the table. So this would be the formula for our specific situation with Jack. So let's move on and do an example from beginning to end using the actual formula rather than investigating with a table. How would you actually answer these questions? So we'll start with if you have $200 to invest for 10 years. I'm going to highlight that. And that means that my p-value is 200. That's the amount I'm investing. And I'm doing that for 10 years. So my n is 10. Now, it's saying, would you rather invest your money in a bank that pays 7% simple interest? So that's option 1. Or would you rather go to a bank that pays 5% interest compounded annually? Is there anything you could change in the problem that would make you change your answer? So we're going to take a look at this, and this will allow us to review simple interest and talk about our new compounded annually interest at the same time. So let's start with the bank that is simple interest. Simple interest, if you remember, was A equals the principal plus the principal times the rate times the time, which would be your interest. So here we would have A equals the principal amount was 200 plus 200 times the rate. Simple interest rate was 7%, so that would be 0.07. And then the time, which would be 10. So this is A equals 200 plus, if I do 200 times 0.07 times 10, I get 140. So that means my value here would be $340. So if I invest there after 10 years, that's what I'll have. Now let's look at our compounded annually. So we'll just say compounded. That bank, we're going to use the new formula, A equals P times 1 plus the rate to the time of n. So here we're going to have A equals 200 times 1 plus the rate. Our rate for the compounded annually bank was 5%, so that'd be 0.05. And then we are going to calculate that to the 10th year, so that goes in as an exponent. So when you type this in the calculator, you're going to get a number that doesn't make sense with money. You're going to have a lot of decimal places. So knowing that we're working with money, we know after we calculate this that this is approximately, so give me the squiggly equal signs, it's going to be 3.25 and then 78 cents when we round. So right now, it looks like I'd rather choose the one that's going to give me more money, which would be simple. However, it says, is there anything you could change in the problem that would make me change my answer? So yeah, 10 years is not that long, really. So simple interest bank is looking better because it's not really that much time. So if I wanted to change anything, I'd probably just have to invest longer, because the longer I invest, remember what happens when you are multiplying pattern. It grows slowly, but then as time goes on, it increases more rapidly. So I would say if 10 years, simple interest bank, because it is more money. However, if you changed the time to be longer, compounded would be better. So I like that example because, again, you get a little review of the old simple interest compared to our brand new compounded annually. And we have that conversation again about how exponential is just a little different because it does grow, but very slowly to start and then more rapidly at the end. So remember, simple interest that we already learned about was about percentage on the principal every single time. So your interest was the same year after year after year. With compounded annually, you're taking the percentage of your most recent total. So the interest is different. It has a rate that it is going up by, a multiplying pattern. So right now, what I'd like you to do is to try the next 3 practice problems on your own, and then resume the video to go over the answers once you've tried those problems. So now that you had the chance to try on your own, let's go over the answers to the problems. In number 1, Rhonda deposited $3,000 in her bank. She earned 4.2% interest, and it very specifically says compounded annually. She made no deposits or withdrawals. Write an equation that can be used to find B, her account balance after T years. So I wrote down the original formula that we're supposed to know. A equals P times 1 plus R to the N. And then I kind of tried to show you that here, though, we're going to say B instead of A, and we're going to have T instead of N because of the way they wrote the problem. So my principal amount was $3,000, that's going in for P, and 4.2 was the percent, so as a decimal, that would be 0.042. So you can see that I plugged them into the correct spots to get a formula of B equals 3,000 times 1 plus 0.042 to the T. Or again, you can add those together and write that number in parentheses instead. In number 2, Jill has 1,000 to invest. It's a 3% compounded annually rate. I want to know how much money will she actually have in the account after 7 years. So here, principal amount is 1,000. 3% would be 0.03, and I'm actually finding a value at year 7. So my formula would be 1,000, A equals 1,000 times 1 plus 0.03 to the N. Then you can see I replaced N with 7 because they want to know how much after 7 years. So rounding accordingly, because this is money, I should have $1,229.87. And lastly, Carlos inherits $10,000 from his uncle's estate. He decides to invest the money in a portfolio of stocks and bonds. Here, 6% interest compounded annually. Decides to leave the money in there for 10 years. So find the amount accumulated at the end of 10 years and round to the nearest penny. So the generic formula I again wrote down. My principal amount was $10,000. 6% means 0.06 is my rate. And I want to find that out for 10 years. So you can see I replaced N with 10. This would be 1 plus 0.06 starting with 10,000. So my value is $17,908.48. And that concludes your lesson on simple and compound interest.